Hi and welcome to Data Garden. Today's video is the third in my series of RStudio for beginners, and in this video we want to dive in a bit into the different classes of data that you can work with in R. So these classes are vectors, matrices, data frames, and lists. Now there are a couple more classes, but these four are the most important. So in the first video of the series we have already created some vectors. So I guess you should be familiar with this. And for the start of this tutorial, let's actually create three vectors that we will continue to work with during this tutorial. So I'm just going to create a vector called color, and I will assign it the values green, blue, red, and another green. Press run, and there we have this first vector. Then we create a second vector, we call it size. And by the way, I am of course completely making these numbers and colors up. They don't have any meaning and they are just for demonstration. So let's say 12, 15, 9, 25. And the last one, weight. And let's say 105, 88, 20, and 122. Okay, so now we have three vectors here. And of course, what we can do is we can, for example, type size times multiplied with weight. And we get the product. So now it would be a bit complicated maybe to always work with these individual vectors, because let's say these are four observations. The first one would be green, size 12 and weight 105. The second one would be blue, size 15 and weight 88, and so on. So it would maybe be nice to have them in a matrix layout so that it would be easier to know which part of the vector refers to which observation, especially if you had not just four, but let's say maybe 400 or 4,000 observations. So we can actually, of course, do this. And we're first going to make a matrix out of it. And we're going to call it matrix 1. Okay? And we assign it with the following: as matrix, opening bracket, and then what we're going to use is a command rbind, which stands for row bind. Or actually, let's change that up and for a start use cbind, which stands for column bind. And we're going to type color, size, and weight, which are the vectors that we have defined previously. And press run, and let's see how it looks. Matrix 1, press run again, and as you can see we have actually it was correct to use the cbind command, of course, because now we have 4 rows now for our observations, and we have 3 columns, one for each vector that we have created previously. Now, just to show you, you can also use the binding by rows, and then it looks like this, where we have 1 row for each variable. This can also be helpful at times, but in most situations you would probably prefer to have it bound like this, where you have 1 column for each variable that you have. Now, let's see what happens if we want to use this same operation, size multiplied with weight, but for these columns in this matrix. So how we can do this is after typing matrix 1, we use these square brackets and we type comma 2, which means that we use the second column of this matrix and we multiply it with matrix 1 and in square brackets comma 3, which means again that we use the third column, and press run. And as you can see, we get an error here. Non-numeric argument to binary operator. And the reason for that is that if we combine character strings with numeric variables, as we do here, the color is the character and the size is a numeric, and the weight is also numeric, then what R will do for a matrix is it will coerce all of the numeric variables into character strings. So even though it still says here 12, you can see that it's in quotation marks. So it's actually a character string and not a number. And as soon as that is the case, you cannot do any computations with it. And that's of course pretty annoying. So now, as a second step, we can make this a bit more comfortable and store the same information as a data frame. So let's define a new object and call it df1 for data frame 1 and type as data frame, and then we use the same command that we have used here earlier. Actually, we can copy paste it if we want to. So as data frame, cbind for column bind, color, size and weight. Press run again. And there we have it. You can actually have a look at it. And as you can see, it looks kind of the same as the matrix below. But what we find is that we now have here 3 columns that are each factor variables. And you will find that this is also a bit annoying. Let's actually try out this same operation, but on the data frame now. And in this case, because it's a data frame, we can also use the dollar operator instead of these square brackets. So df1 size multiplied with weight. Press run. And as you can see, it still doesn't work. This time we get a different error. Multiplying is not meaningful for factors. So in this command where we define the data frame, we can actually add something after this part where we have defined the data. We can type comma and then strings as factors with a capital A and capital F equals false in all capital letters. Press run again. And let's look at the data frame again. And now you can see that we have all character vectors, again, like it was in the matrix. Now, this is still not quite what we want. So in order to be able to do our calculations, we will still have to do 2 more steps. So let's create two new lines here and press type df1 $size and assign it a new value as numeric df1 $size. Press run and do the same for the weight variable in the data frame. Press run, and as you can see, now we can actually calculate these computations. Now you might ask, why would we type this strings as factors equals false if we still have to change the type of the variable here? The reason is, if we don't do this, then we will actually get skewed up values here. We can actually try that out for a moment, just for a test. redefine it and run these two. And as you can see, we have lost our original values, and we have just 1, 2, 4, 3 and 1, 4, 3, 2, which are the factor levels that R has assigned to these numbers that we have defined. So be very careful with this. If you do not have the strings as factors as false, then R might very easily skew up your data without you even realizing it. And with these numbers here, it's still very obvious. But imagine if you have a couple hundred rows, then you might not even notice it very easily. So yeah, I recommend you always work with this. Alternatively, you could always type, instead of as numeric, you can type as numeric, as character, and then the variable that you want to change. With this variation, you're always on the secure side. So yeah, I also recommend that you would usually want to use this one instead of typing just as numeric, so that you can be sure that R does not skew up your data in some way that you do not want. Now, I hope it has been getting clear now already, but the big advantage of the data frame compared to the matrix is that in the matrix in R you can only have one type of variable, which would usually be either numeric or character. And as soon as you have some character variables or values in your matrix, all of the values will be coerced to character. Whereas in a data frame, you can have different variable types for different columns. So in this case, green is a factor and the other two are numeric. So this makes it very helpful to work with diverse data. And as soon as you have some words and some numbers in your data frame, you will have to basically work with the data frame instead of a matrix. Now, there are some inputs that will, some operations that will require you to work with matrices, but apart from these, I will recommend you that you only work with data frames. Now, there's one more thing that I want to show you in this tutorial, and that is lists. So what we can do is, let's create a new object called list1 and say that the command is lists, and we type color, size, weight, and df1, press run, and we have just created a list of 4, and it has all of the objects in it that we have just created. Now, you may not find this too useful for now, because it's just a different way of storing things. For example, if you work with a very big project, you could store all of your data that is related to one topic in one list, and all the data that is related with another topic in the second list, so that you bring a bit of order into your data. But lists can also be valuable for other things, such as applying a command to a couple of different data frames of similar structure. So imagine you want to, for example, calculate the row sums of data in a couple of different data frames. Then you could do this with a for loop for every data frame in just one command, instead of using the same command 10 or 100 times for each data frame. So we will get more into how to work with lists and for loops or apply commands in one of the next tutorials. But for now, I just want to show you what these kind of data types in R are, how they work, and what to do with them. I hope you have found this video helpful. If you have, then please give it a thumbs up. If you want to see more videos of this type, then I would be very happy if you would subscribe to the channel and maybe click the notification box, because I have more content coming up very soon. Thank you for watching and bye bye.